Imagine a universe where the night sky is filled with not just one, but multiple suns, each with its own unique dance and rhythm. As we gaze up at the stars, we often take comfort in the predictability of our solar system, where our sun reigns supreme, guiding the planets in a harmonious orbit. But what if I told you that out there, in the vastness of space, there are star systems so strange and complex that they defy everything we thought we knew about the cosmos? What if the solar system we call home is just one of many possible cosmic arrangements, each more bewildering than the last? Prepare yourself for a journey into the unknown, where the rules of gravity are bent and twisted, and where star systems exist in configurations so bizarre that they challenge the very fabric of our understanding. Welcome to the world of cosmic quartets, binary stars, and the mysterious HD 9800 system, a place where the ordinary becomes extraordinary and the known becomes the unknown. In this video, we'll uncover the secrets of the HD 9800 system, a star system so unique that it has astronomers questioning the very nature of planetary formation. We'll explore the strange and often mind-bending configurations of multiple star systems, including binary stars that hold the potential to host alien life. Along the way, we'll delve into the mysteries of protoplanetary disks and their role in the birth of planets, revealing how these cosmic phenomena can exist in orientations that defy all logic. Stay with us as we embark on this cosmic adventure, where the unexpected becomes the norm, and the mysteries of the universe unfold before our very eyes. Our Earth does not move randomly or alone through the universe but is an integral part of a superordinate constellation, which in our case we call the solar system. The eponymous host star, the Sun, serves the 8 planets and their moons, but also the dwarf planets, other small bodies like comets, asteroids, and meteoroids, as well as the totality of all gas and dust particles, as a central fixed point to which all these entities are gravitationally bound. A look beyond the boundaries of our solar system reveals that the cosmic variety of such systems is significantly larger than many would assume at first glance. In fact, our home solar system is only one of many possible compositions of gravitationally bound celestial bodies. Just how manifold these cosmic assemblies can be in reality was reinforced by terrestrial experts when they identified some time ago an unusual star system, one that puts everything known so far to shame. This surprising constellation is forcing astronomers to rethink their understanding of star systems, and in this video we explore what makes the HD 9800 and other systems so special. From the basics of multiple star systems to the mysteries of the protoplanetary disk HD 9800, we explore the world's most fascinating species. As we said at the beginning, our solar system appears to be influenced by a single celestial body. The fact that bright objects merge, sometimes forming binary star systems, has long been known to scientists. In fact, the existence of so-called quadrilateral star systems, consisting of 2 separate pairs of stars, has been proven before. Similar star clusters surrounded by a large ring of gas and dust, a so-called protoplanetary disk, is also part of the basic knowledge of astronomy. But to fully understand the features of that constellation, it is necessary to take a closer look at the star system HD 9800, located 146 light-years from our blue planet. For a long time, a group of celestial bodies appeared that resembled the characteristics of the known star systems. However, a recent study of the surrounding protoplanetary disk revealed that HD 9800 is one of the most unusual structures scientists have seen in recent times. This system consists of an outer and an inner pair of stars. The inner pair, called BABBB, is separated by a distance equal to the distance between the Earth and the Sun. The 2 outer stars, known as AAB, are far apart. In detail, the galactic gap between these 2 celestial bodies has been determined to be 54 astronomical units, or AU for short. To clarify, 1 AU is equal to the average distance of our home planet from the Sun, or 90 million miles. In other words, the exoplanets are far away from the Sun and Pluto. The distance between the oldest member of our planetary system and the host star is only $40. So, despite the great distance between the silent outer stars, their inner companions, or the protoplanetary disk around them, can be much better viewed. In fact, the circular disk always lies on a plane parallel to the orbital plane of the two constellations. But scientists have now discovered that this simple design cannot be applied to HD 9800. In fact, the protoplanetary disk here is located directly in the plane of the inner pair. In the scientific community, this constellation is called a polar configuration. Basically, the disk does not move east-west, but north-south. To illustrate this, we can think of the inner pair of stars as a carousel horse in an amusement park, revolving around a common horizontal center. However, in this metaphor the outer circular disk is, in this metaphor, an inverted form of happiness. Before the various features of the HD 9800 were tested, these global systems were only in theory. How profound this discovery is in the wider galactic context becomes clear when we consider the protoplanetary disks where the planets reside. Given this background knowledge, it's not surprising that after their groundbreaking discovery, experts were immediately eager to find out whether planets could also form in those disks that have such an unorthodox orientation. Despite this strange configuration, valid features were detected in HD 9800 that clearly point to an early phase of planet formation. How the further development of the celestial bodies will take shape in the future, however, is still literally written in the stars. So, experts cannot predict at present to what extent the planets can form permanently within such a seemingly chaotic system and ultimately stabilize at all. Although there are still many mysteries to be unraveled regarding this fascinating constellation, leading astronomers are already certain that we will find many more such cases in the future. Therefore, the next challenge for researchers is to identify appropriate systems at different stages of their development. The discovery of planets that have already formed in these systems may also be an important clue. Based on this exciting discovery, a general overview of binary star systems is recommended. Often when similar celestial bodies are close together, a star appears naturally in our terrestrial view. Because the celestial bodies are tied to each other, they form a physical unit, that is, they rotate together in a center of energy. Although at first one might think that the combination of two stars is rare, the story is different. According to current estimates, 70% of all stars in the Milky Way are part of a supermassive system. If another star or stars join this galaxy cluster, it is called a multi-star system. In the classification of binary stars, experts distinguish between different types. For the reason just described, celestial bodies that are bound by spatial proximity in orbit around a center of gravity are called binary stars. In front of these are bright binary stars, a common galactic defect. Therefore, some stars, seen from the Earth, have the same direction in the sky. But the truth is, these two stars are so far from the Earth that they do not influence each other. Finally, the international team is completed with double stars and geometrical triangles. These are celestial bodies that are close to each other but are not bound by their relative velocity. Although physical binaries always revolve around a center of gravity, the collision of geometric binaries is a unique event. Typically, physical binary stars have a brighter main component and a fainter companion. Orbital periods in this system vary depending on the distance of the stars. Although in some cases a pair of stars may take only a few hours to complete a complete orbit, in extreme cases it may take thousands of years. Celestial bodies traveling at greater distances only interact with each other. However, if the distance between the stars is small enough to exceed the so-called Roche limit, mass transfer between the luminous bodies often occurs. In some constellations, the dominant distance is so small that the stars combine to form a single fold. Planets also exist in binary star systems. Basically, the different types of planetary orbits are divided. Exoplanets assigned to Type S orbits are only one representative of this pair of stars. The planets in question are not in contact with their counterparts because they are too far away or have too little mass. The situation is different for P-type planets. These exoplanets, orbiting a binary star, are far from their host. It must have enough distance to avoid touching another object, so it will continue to orbit forever. Finally, this is accomplished by T-type exoplanets. In these constellations, a binary star transits a planet in what are known as Trojan signs. These are points of equilibrium in the orbit of a celestial body around which other smaller bodies can be placed. Because of the great distance between these two systems, most of these T-types are found in binary star formation. Currently, experts estimate that 50% of all binary star systems have their own exoplanets. Like the previously mentioned HD 9800, scientists are also interested in identifying other exoplanets in the system that have more unique characteristics. Do the above-mentioned celestial structures represent a galactic standard that would outlive life on Earth? How many exoplanets might have formed in systems with more than 2 stars? What if they have other people's lives? We may only be scratching the surface of these mysteries, but with each discovery we come closer to uncovering the vastness and diversity of the universe. Join us as we dive deeper into these questions and explore the possibilities beyond our solar system.